Hi there. Well, it's good to see you guys. I want to move this down a little bit. Okay, whoa. All right. Okay, well, what we're going to start in chapter 5 are decimals, and which is kind of nice. I think they seem to be a little easier to work with than fractions, mainly because you can use your calculator easier with them. Well, we're just going to review here the place value of decimals. Okay, and I will try to upload this little chart here so you can use it on your tests into Canvas, and so you can just run it off. I'll put it into a file and put it onto Canvas. I should be able to do that pretty easy. But anyways, what we've done is we worked over here with the ones, tens, hundreds, thousands, 10,000s. Now what we're going to do is we're going to only have parts of the ones. You know, we'll have tenths, hundreds, thousands, 10,000s, 100,000s, and millions. So when we're dealing with these over here, these are actually fractions. So in other words, we only have a part of the one. Okay, we don't have an entire one, we only have part of it. Tenths is just what it means. So decimals and fractions, they're just two different ways of writing the same amount. So a tenth is 1/10. All right, if we had 1/10, so that it represents tenths. So these represent fractions, but the denominators are pretty specific. If it's here, the denominator is tenths. So you've divided something into 10 equal parts. Here is 100ths. So if you're dealing with something in this spot, it's hundredths. So they're fractions with specifically designated denominators. Here would be thousandths. So you would have pieces in thousands. So, you know, they're getting pretty small. If you're taking one and dividing it into 1,000 equal pieces, it's pretty small pieces. 10,000ths, and again, extremely small. You've divided something into 10,000 pieces. This numerator tells you how many of those you've got. So these get pretty small. So we've got tenths, hundredths, thousandths, 10,000ths. Notice that we all have a THS. So that just tells you where you're at in this whole scheme. Tens, hundreds, as opposed to tenths, hundredths. Just remember that when you go past the decimal here, let me move it down just a smidge. Okay, when you go past this decimal over here, we don't have a once. All right, so you start with tenths. So we've got the tenths, the hundreds. Over here on the left, you start with the ones. All right, so that's kind of the only difference. And then you have the THS. So just think about how small millions would be. You're taking something and dividing it into a million pieces. You're dividing something into a million pieces, and that numerator would tell you how many of those you have. 1, 2, 3, 4, 5, 6 zeros in a million. And this would tell you how many of those pieces you've got. So again, they can get very, very small. But we're going to be looking at these right here, and you're going to be able to, or you'll be expected to go from a fraction to a decimal and a decimal to a fraction. So we'll work both ways. We'll be able to go from one to another. All right, so let's look at some examples here. All right, so if this would be read 24 and, so the decimal is our word and, 24 and 300ths. So you read this, and then where the last place is the name you attach to it. So this would be 24 and 300ths. And to write it, I would write 24 and 300ths would be one way of writing that. And they'll have you write it out in words too, and we'll practice that. But 24 and 300ths. Here, another example. This one would be read 152 and, you read 205 and you go to the last place, which is thousandths. 205 thousandths. All right. So the last place here is the name that you'll use. So 152 and 205 thousandths. Okay, let's look at another one. And again, we've got some practice here. Normally we put the 0 here. Actually, sometimes I forget, but it's just kind of a placeholder. So you have 0 point. But here we have the number 3. So you would say 3, and you would go tens, hundreds, thousands, 10 thousandths is the last spot. So this would be 3 10,000ths. All right, so that's kind of how you read these and how we'll write those. All right, so let's look at some examples. If we need to, we can come back to our chart. First, we'll start with number 5. Some of the things you'll need to do is to write in words a number written as a decimal. So you would write 6 and for the decimal. This is the number 1 and it's in the 10th spot. 1/10. Okay, so that's how you would write 6 and 1/10 is how that would be written. All right, let's look at this one right here. 400, maybe kind of tedious, I don't know. 420 and, so we're to the decimal, 420 and 769 60, put your hyphen, 9. And this is in the tenths, hundredths, thousandths. So 769 thousandths, tenths, hundred, thousandths. Don't forget the THS, it matters, okay? So 420 and 769 thousandths, no problem. Let's do another one. 27, right, little. Then we come to our decimal and 562. So we write 562. Tens, hundreds, thousandths, 10 thousandths. Tenths, hundreds, thousands, 10 thousandths. They do hyphenate that. Don't forget the THS, okay? All right, so this one would be 6,554 and 17 10/100ths. All right, is how you would write that one out. Okay, so that probably gets you started on writing these decimals as word. Now we're going to go ahead and we're going to write these decimals as fractions. The nice thing is, do not simplify. So we do not have to reduce our fractions. Yay. So this one right here, 12. Where does the 2 end up in? What spot? Well, we've got tenths, hundredths. And you're done. 12 hundredths. This one right here, 31 and 746 tenths, hundredths, thousandths. So we write it. And again, this was tenths, hundreds, thousandths. And then we're going to look at going from this to here, and you can see that that 31, the decimal will stop there. Oops, I don't want that decimal in there. So you put this whole number part, also all of this without the decimal over the thousands. Okay. Good. All right, let's look at this next one. 6 and 4,207 tenths, hundreds, thousandths, 10 thousandths. Yep, so 10 thousandths, because the 7 is in the 10,000th spot. These here just kind of go along. All right, so these are equivalent in value to this. This is equivalent in value to this, and this is equivalent to that. All right, so again, these decimals are fractions. You just have to have a specific denominator, and they're all based on zeros, and which is really nice. Zeros are really easy to work with. Okay, all right. Now, given a decimal, or excuse me, given a fraction, they want you to write it as decimal notation. Well, this is actually pretty simple. So what we'll do, focus that a little bit. I want to show you that I'm going to do an example here. I don't think I had it written out. I may have. Nope. So I will write it out now. See if you can see a pattern. Mathematics is the study of patterns, and this might help you to remember. So we have, let's say we have 5. Let's go 53. Let's do 53.7. Now, if we were to divide this by 10, the answer is, okay, those are equal to each other. Now, if I took 53.7 and divided it by 100, I get 0.537. Okay, so you notice I'm not changing the value here. When I'm dividing by 10 or dividing by 100, I mean, the numbers themselves haven't changed. Notice the decimal and what's happened to the decimal as we do this. All right, let's do another one. 53.7 divided by 1,000. Okay. And again, the numbers haven't changed, but the decimal place has. So I'm hoping that you realize that when I multiplied by 10, there was 1 0, and I moved it to the left once. Okay, to go from here to here. These are equivalent statements. And then with this one right here, dividing by 100 that has 2 zeros, I moved it from where it was after the 3 to the left twice. Here, all right, I'm dividing by 1,000 that has 3 zeros, and I from where it's at here, I will move it to the left 1, 2, 3 times. So when you're dividing or multiplying by tens, hundreds, thousands, 10,000s, if you multiply, you move the decimal to the right, the number of zeros you have. In division, you move it to the left, the number of zeros that you have. And so it just makes it faster than reaching for your calculator every time. So we've talked about multiplying. You move it to the right, the number of zeros. Now with division, you'll move it to the left, however many zeros you've got. So let's practice this here. All right, so looking at number 12, the problem is where is the decimal? Well, if the decimal's not given, the decimal is at the end here. So I'm going to take the decimal where it's at, and I'm going to move it to the left because it's division twice. So it will be 5.34. Okay, pretty easy. Here, the decimal is at the end. I'm going to move it to the left 1, 2, 3 times. So it was here. It was after the 3, 1, 2, 3. And there you have it. So this statement and this mean the same thing. These two are equivalent amounts. All right, let's look at this right here. We have 49 and 7,600 thousandths. Well, we're going to move our decimal to the left. 1, 2, 3, 4, 5. So we have 49.1, 2, 3, 4. Let me see. I may have too many zeros in there. 1, 2, 3, 4, 5. I do. I only needed 4 zeros. It's an easy fix. One, 2, 3, 4, 5. Okay. So that would be 49 and 7,600 thousandths is how that would be read. So that's also how to handle that. 49, you've got your decimal here. All righty, so that is kind of a quick overview of how to go from a fraction notation to decimal. So we've gone decimal to fraction, and then now we've gone from fraction to decimal. All right, those two examples. Let's carry on. All right, now what we're going to do is we're going to learn how to determine which one is larger and which one is smaller. Sometimes this can give people some trouble, so we'll try to go through it carefully and slowly. In looking at this, in order to be larger, it has to be to the right on a number line. And that's not hard until you get to negatives. Okay, so that then it's not quite as intuitive. But when we're in positives, you look to the right. So first off, look at the 23s. Okay, they're the same. All right, if they're the same, you're going to go to the next number. The next number here after the decimal is a 0. I don't care about the 8, you get to go in order. So you've got a 0 and a 4. So you have 0 tenths and you have 4 tenths. Because the 4 is larger than the 0, this number is larger. So here, okay, you just move from left to right until you come to a different number and compare those. I don't care what's happening afterwards, and that's hard for some people. But here you're comparing the 0 to the 4. All right, and the 4 is larger, so this number is larger. Let's go ahead and work on our positives again. Let's look at 17, and then we'll come back to 16, which is a negative. The 8s are the same, the 5, so we've got 85 and 85, they're the same. So then we have, after the decimal, I have a 0 and a 0. Those are the same. So we'll go to the next number, a 3 and a 2. 3 is larger than the 2. So that one's bigger. You don't care about the 8, we didn't need to. If you had to compare the 8 and there was nothing here, you'd put a 0, but we didn't. We had a 3 and a 2. So as soon as you have different numbers to compare, then you don't care what follows those numbers. All right. Okay, let's look at the negatives now. Here we have a -9, -9. We have 0.4, 0.4. This is a 0. So if you need to, for comparing purposes, you can put a 0. All right. So now it means that this number is to the left, all right, because you've got negative, you have 9, you have 4, 0, and 6. Because this is negative, the 6 is on the other side. All right. So it would be actually -9.461 and then -9.400. Okay. And again, you can add as many zeros as you need to. So here, this one is actually to the left. So this one is larger. So you've got 0.4, the 6, because it's negative, is larger than the 0, it's going to be further to the left. Like the same idea that a -2 is to the left of a -1. Okay, it's to the left. this one's to the left. So that means this one is larger. So the negatives are a little bit more difficult than working with the positives. All right, so that's how you compare numbers. One way. I suppose there's other ways. There are other ways. You can make them the same denominator if you wanted to, but we'll just compare them in order. Okay, now we're going to look at some rounding. Whoa. Now, in order to round, you need to understand your place values. So this is just like what we have done earlier in chapters 1 and 2. I don't think, yeah, in chapters 1 and 2, where we had to estimate and things like that. So we want to round to the nearest hundredth. So we're going to go to the hundredth and we're going to look to the right. If it's 5 or greater, we'll increase it by 1, the hundredth spot. But if that number to the right is 4 or less, we're going to keep that hundredth spot the same. So here, tenths, hundredths. So the 4 is in the hundredth spot. So I'm going to look to the right of the 4. And that is 5 or greater. So I'm going to increase the 4 to a 5. So we have 632.55. Okay. Everything past the hundredth spot just drops off. All right. You don't need to make them zeros. They can just drop off since we're on this side of the decimal. Okay. Let's do another one. Round 3 and 203 tenths, hundredths, thousandths to the nearest tenth. So we're going to go to the 10th spot, which is right here. Right after the decimal is the 10th. We're going to look to the right. It's not larger than, it's not 5 or larger, so the 2 is going to stay 3.2. We didn't have to increase it. Okay. And then we just drop everything past the 10th. Okay. Okay, on number 20, just a second here. We're going to look at, I'm going to need to move this. Sorry, 1 second. All right, so we're going to look here, round to the nearest 10,000th. Let's go ahead and look at the 10,000th, tenths, hundreds, thousands, 10,000. Right there. All right. So we're interested in that spot. We're going to look to the right, and it's 5. It's over 5. It's 5 or bigger. So we're going to increase this one. Instead of, we increase this one by 1. So 49 increased by 1 is 50. So when you have that 9, you'll end up increasing that next number. So we're going to go from 49 to 50. Okay, notice I put that 0 there because I wanted to round to the nearest 10,000th. So I wanted to make sure I went to the 10,000th. Tenths, hundred, hundredth, thousandth, 10,000th. So I did put that 0 because I wanted it to end. Like on this one, we ended in the 10th spot. Here we ended in the 100th spot. Well, here I ended in the 10,000th spot. All right. So again, that's just kind of a quick review of rounding. And that does that for section 5.1. Let's look at 5.2. Well, 5.2, I won't spend very much time on 5.2. It's adding decimals. You just need to remember that when you are adding decimals, well, here, let's look at some of these samples that they give us. You have to line up the decimals. And the reason you want to line up the decimals is because you have to add common denominators together. So we have to have the tenths, all right, the hundredths, the thousandths. So we're adding common denominators is what we're doing. So you've got 1,000th and 3,000th gives you 4,000th. thousandth. So again, it's important that when you add or subtract, because we have to have common denominators when we add or subtract, so you need to line up the decimal so that you're adding like denominators, right? And if you do that, they'll line up if you put the decimal there. All right, so again, line them up so that you're adding common denominators. It makes it so that all the tenths line up and all the hundredths will line up, thousandths line up. So looking at number 8 here, we have 0.97 or 0.97. We need to go 0.113 to add those together. And and you could put a 0 there because you don't have any tenths, hundreds, you don't have any, you have 0 thousandths, and if you want it to really line up, or you don't have to put that 0 there, you would just take nothing plus 3. So you're adding the thousandth. It's just that this first number didn't have any thousandths with it. So the 3 thousandths. 8 hundredths. Here we have 0. You do bring the decimal down. Okay. So we actually ended up with 10 tenths, which is 1. So you bring it to the 1 spot. 10 tenths is 1. All right. So, just like I say, line up the decimals. If you look at number 9, on number 9, the decimal on the 83 is right here. So it's 83 points. So if it's not there, it's at the end. And then you'll put 8.231. And if you want to, you've got 0 tenths, 0 hundredths, 0 thousandths. So you can put those zeros in if you're so inclined, so it looks better. And then you start, you've got 1 thousandth, 3 hundredths, 2 tenths, and then you can just add up the other ones. You come up with 1191 and 231 thousandths. All right, quick review. Subtraction the same way. Addition and subtraction, you have to add like denominators. So you do have to line up the decimal. So the tenths, hundredths, thousandths, 10,000s all line up. All right. Oh, I guess that's it for adding and subtracting. I thought maybe I had something else, but I don't. Okay. Multiplying. Multiplying has its own rules. I don't know. You don't line up the decimals when you're multiplying. You don't need to line up the decimals. And so what we do, we just have a general rule. First off, you go ahead and you multiply as if the decimal didn't even exist. So you just totally ignore the decimals when you're multiplying, just as a quick review. 6 times 1 is 6. 6 times 6 is 36. Excuse me. And then you count the decimals places. 1. And that's it. So you go over 1, 36.6, okay? Oh, let's do another one. Oh, okay, let's do number 6. Number 6 is fine. We'll do that. So again, 3 times 7 is 21. 3 times 4 is 12, plus 2 is 14. 3 times 1 is 3, plus 1 is 4. Okay, now we're going to go to the 10. So you put a 0 there. We're in the 10 spot with the 6. Don't forget your 0. 6 times 7 is 42. I'm going to cross that one off. And then 6 times 4 is 24, but you have to add the 4, and that gives you 28. 6 times 1 is 6, plus 2 is 8. Add them together. 8 is 12, 9. All right. So we just kind of multiplied it across there. We added our 0. My 8s look really weird, but that's okay. Now, the decimal. Okay, now, because again, you just kind of ignored the decimals. So now I'm going to count. 1, 2, 3, 4. You add them all up, both numbers. So 1, 2, 3, 4. 1, 2, 3, 4. Okay, and you can always, you know, you might want to, you can practice that and then check it on your calculator, and I think you'll be fine. All right, that's a quick overview of multiplying. However, there's a few tricks that we can do. Let me get another piece of paper to cover up some of these so it's not so confusing looking. Okay, now, how can I quickly take 0.1 times 31.76? Okay, this idea is very similar to, okay, let's say I wanted to take 17.6 times 100. All right, I would move it to the right twice. I would move this decimal to the right twice. So 1760, 1, 2, okay? All right, if I divided by 100, I would move the decimal to the left twice. There's 2 zeros, 1, 2. Okay. Well, what about something like this? All right, this is actually 1/10. Okay, this represents 1/10. So I could rewrite this as 1/10 times 34.76. Because it's 1/10, it's actually a division with 1 0. All right, so I'm going to make that a times because they have an X there. All right, so here you would move the decimal to the left once. So this is 1/10. It's actually a division. This 10 is in the denominator. If you were to multiply across, it will look just like divided by 10. Okay, so you'll move your decimal to the left once. So 3.476 would be the answer there. 3.476. You move it to the left once. Well, this is tenths, hundredths, thousandths, 3 zeros. So you're going to move the decimal to the left 3 times. Another way to look at that is if you wanted to take if 1, starting here at the end, 1, 2, 3. That's how many times you'll move it to the left because you want that decimal right there. So this is, or just tenths, hundredths, thousandths, which means you'll move this to the left 3 times because there's 3 zeros in 1,000th. So this would be a negative 0.0427. So I took it here, 1, 2, 3. And it is a negative. All right, so again, don't forget those negatives. Sometimes they're easy to forget, but try not to. My math lab won't like it. So again, this is in the thousandth, 3 zeros in 1,000th, move it to the left 3 times. This one, though, you'll just move it to the right twice. So 5, 1, 4, 0, 1, 2, okay? Because it's just 100. So again, you can convert these, which means it's a division, so you're moving your decimal to the left. Here, you're moving your decimal to the right, the number of zeros you've got. All right, good. Hopefully you've got that. All right. We're going to be converting from dollars to cents, which is actually moving the decimal, going from dollars to cents. And it kind of amazes me when I read in some flyers and stuff that people have, they've written their cents like 20 cents or 33 cents incorrectly. So we'll try to clear that up. And also there are some story problems where you'll need to convert you need to go from dollars to cents just because you'll be creating equations. And we really don't like to have decimals in equations. So if you can convert it to cents, then you won't have any of those. All right, so again, $51.39. We want to convert this to cents only. The key is that there are 100 pennies in every dollar. So this 0.39, even though we say 39 cents, it's actually $0.39. So to go from dollars to cents, you're going to multiply by 100 because every dollar has 100 pennies in it. So you're going to take 51.39 times 100. So this gives us 5,139 cents. All right. We usually put the cent sign afterwards. So my math, I do that. Yeah. Okay. That's all there is to it. So if I have, all right, this right here means 12 cents. And I've seen people put a cent sign here, 0.12 cents, which is not correct. This means 12 cents. Okay, if you have the 0.12, it's in dollars, but we read it 12 cents. So we're going to take 0.12, which is in a dollar now, it's a dollar sign, times 100, 12 cents. So these two mean the same thing. 0.12 with a dollar sign is the same as 12 cents. Multiply by 100. So don't get those mixed up. Here, we read it as 7 cents. But here we'll multiply by 100 to change this notation, dollar notation, $0.07 to cents. And we'll end up with 7 cents. So to go from dollars to cents, you multiply by 100 and change your units from a dollar sign to a cent sign, a dollar to a cent, a dollar to a cent. Okay, let's go the other direction. Well, I know that if I multiply by 100 to go from a dollar to a cent, I will divide by 100 to go from cents to a dollar. To go the other direction, I will divide by 100, which means I'll move the decimal to the left twice. So I move the decimal to the left. I put the 0 there as a placeholder, and I put a dollar symbol. So these two mean exactly the same thing, whether or not you want to use a dollar or cents. Here, divide by 100. So you'll move the decimal to the left twice. 2. Okay, $24.77. If you had 2,477 pennies, you have $24.77. Okay, what happens if you have 4 cents? How many dollars? How could you write that using a dollar unit? Take 4 divided by 100. So that would give you 0.04. Move it to the left twice, and it's $1. So it's just a matter of moving the decimal right or left to go from dollars to cents. Okay, you're going from a larger to a smaller unit. It takes more of them. So you multiply and move it to the right twice. To go from pennies to dollars, you'll need less of them. So you'll move it to the left. You'll divide by 100. And so it's all based on 100. Perfect. Good job. All righty. Next. All right, so here they want you to be able to convert to standard notation. All right, so for standard notation, what do they want when they say put this in standard notation is they want you to write it with zeros. So here you're just going to have to write the million. Now million means you've got, okay, you've got one spot here. Here's your thousands, period. There's your ones period. So they want the 5 here in the million spot. So then you've got 4, 3, 0, 0, 0, 0. And that's 5.43 million. Okay. So the 5 will be in your million spot there. Here in 2014, Facebook was used by 1.35 billion people around the world. They want you to convert 1.35 billion to standard notation. Billion, so we've got our ones here. We've got our thousands period, our millions period. Oh, that's kind of a little high there. And there's our billion. It looks like we're only going to have one number in the billion spot. So 1, 3, 5, and then you put zeros everywhere else. So ones, thousands, millions, billions. So that's standard notation. They want you to put the zeros in there. Okay. All right. Now, last thing we're going to look at is some evaluating. Okay, what I have here is the volume of a cylinder. Okay, this is the base area, pi r squared. There's our 3.14 is pi r squared is the base. It's a circle in a cylinder times the height. So they want you to be able to use formulas. It's not really too difficult. What we're going to do is we're going to say that the radius is 2. They're not giving us any units, just 2. And the height is 0.05. So I'm going to take these and substitute them in for the R and the H and use our PEMDAS. So what we've got, we have the volume is equal to 3.14, that's part of the formula, times the radius squared, so 2 squared, times, because they're next to each other, so we're multiplying, times 0.05. So I'll be multiplying those 3 together. You do, in PEMDAS, you're going to do exponents before you multiply. So doing that, 3.14 times 4 times 0.05. Okay, when you're multiplying these together, the order doesn't matter. If you wanted to, you could take the 3.14 times 0.05 and that answer times 4, okay? Or you can multiply these two together and that answer times here. Or you could even use your calculator here multiplying these numbers together. All right, so which I'm going to do. So I'm just going to use my calculator. So we've got 3.14 times 4 times 0.05. And the answer is 0.628. Okay, just assuming that you know how to multiply decimals. So get 0.628 as the volume. It would be cubic centimeters, cubic inches, cubic feet, cubic meters as far as units go. All right, let's put our numbers into our next formula. This is a physics formula. It deals with velocity. Actually, the V is velocity, and this A is acceleration, and the T is time. So we're going to go ahead and we're going to substitute these in. V right here is 17.3 plus our acceleration looks like they're using something close to gravity, 9.8, or a lot of times they use 10.1. Acceleration due to gravity varies depending upon where you are on the earth. So we're going to use 10.1. And the time is 3. I'm going to use parentheses rather than a dot because we've got decimals and parentheses look a little different or look a little cleaner. All right, so I just put in these values for these variables and I use my PEMDAS. You can multiply these together first. So that would give you 3 times 1 is 3 3 times 10 is 30. Okay, 30.3. And again, you could, if you wanted to, just 3, 0, 3, move it over once, move it over once. Okay, 30.3 plus 17.3. And again, if you were to add these together, you make sure you add the tenths with the tenths, common denominators. So this would give you, and if you wanted to, going back to our one section, you could even line them up. 6.7, all right, 47.6 meters per second would actually be the units. They don't seem to care about the units, so we'll just go with 47.7, or excuse me, 47.6. Well, that pretty much covers those first 3 sections of chapter 5. Yep, that's all I have. So, you know, I know I keep telling you, if you have questions, please let me know. And I will be happy to help you. All right, well, keep doing the homework. Please keep up with it. And I'll try to get these next sections out so that you can get started with it soon. All right, thank you. Bye-bye.